container services on AWS. So we have different services on AWS for supporting this containerization. Okay, those services are, first of all, ECR. ECR stands for Elastic Container Registry. It is a fully managed Docker container registry provided by AWS. So apart from ECR, what other registry do we have? We have Docker Hub as well, right? But this is native to AWS. Then we'll be talking about ECS, that is Elastic Container Service on AWS. Then we would be talking about EKS, that is Elastic Kubernetes Service on AWS. And lastly, we would be talking about Fargate. Okay. So ECR is the place where you can store, manage, and deploy the container images. Okay, it provides a secure and scalable way to share your container images as well across different environments. So it provides us with the public registry or the private registry. It can integrate with other AWS services. So we would be talking about features and benefits, right? But before to that, we would be just talking about how this would work. So see, here it also supports versioning, right? So you can see, if we have different microservices, okay, let's say I have microservice for orders or container created for orders. Then I have container for profile, for product. Then for different containers, we can have different container images. And we can have different versions of those images as well. So you can pull out a specific version, or if you do not specify the version, it would be automatically taking the latest version that we have. So what are the benefits or the features of ECR? So first of all, it is fully managed service. So it handles all the aspect of container management, container image management, right from scaling to patching to security. Everything is managed by AWS. It integrates with services like ECS. Obviously, in the previous slide, we understood that once we create the image, we have to pull the image out of registry and we have to create the container from that image. So for creating the containers, what we'll be using? We'll be using ECS or EKS. Right. So because we want that container image to be pulled in ECS or EKS, that's why it should be able to integrate with AWS services, right? So ECR will integrate with these two services. Apart from that, it will also integrate with code pipeline. This service is for having the CI/CD, paradigm. So if you want to build your pipelines for the CI/CD environment, then you can be using the code pipeline service. So basically, when you want to follow the DevOps approach, this would be good. So it makes it easy to deploy and manage containerized application. The next feature is secure and reliable. So it provides a secure and reliable environment for storing the container images. It supports encryption at rest and even in transit. It supports access controls and availability across multiple availability zones. It is scalable and cost effective. So with automatic scaling, you go with pay as you go pricing. You have integration with AWS Cost Explorer as well. So you can do the cost optimization. So Cost Explorer is a service which helps you do the cost optimization. It shows you if you are paying for idle resources or other cost related features are being shown on that particular service. So scaling is supported over here. Pay as you go pricing is there. So all of this make it as cost effective service. Then you can have private registry. So ECR is a private container registry, meaning you can control the access to your container images and keep them secure within your AWS account, right? So if you do not want to give a public access, then you can just stop that. by using the access control methods. So these are some of the benefits of or say features of ECR. The next topic that we are going to discuss about is ECS. So when we talk about ECS, we have 3 steps in running the containers. Okay, the first step was pulling the image. So where this image would be pulled from? It would be pulled from ECR. The next step was creating the container. Right. Creating container from image. So this would be created using ECS. The ECS is a service for container orchestration, which allows you to run, deploy, and scale containerized applications on AWS. So if you think about ECS, it is a service which allows you to create your containers and run your containers. Okay. So let's take another example over here, or another analogy by which you can easily understand this. So again, we would be going to a restaurant. Okay. And imagine yourself as a chef. So we would be comparing the docker with the chef. So Docker is just like a chef who prepares and packages the food. So it provides the tools and the environments to create and package the container images, which can be compared to preparing and cooking the food. So Docker is focused on individual containers and how they are built and run. Similarly to how a chef is focused on individual dish and how they are prepared. Okay, so that is Docker. And with the ECS, we have to understand that ECS would be doing the very similar thing over here. Okay. Another example can be taken over here. Like you could be comparing the ECS to team of construction worker working on a building project. Okay, so in this analogy, the building project will represent the application that needs to be deployed, while each construction worker represents the container. So what would be the role of ECS service over here? It would be just like project manager who oversees the work of the construction team and ensures that everything is running smoothly. So ECS would be overseeing the containers and would be seeing that everything is running smoothly. Okay, so just as project manager assigns specific tasks to each construction worker. Now see over here, I will just note it down over here for a better understanding. So what is building project? Building project is representing our application. Then we have construction workers. So these are representing our containers. And then lastly we have ECS, who is representing as project manager. So project manager assigns specific tasks to each construction worker, right? So ECS will also assign specific tasks to each container. These tasks could be anything from running a specific application component to handling a specific incoming request. Project manager will also coordinate the work of construction team, ensuring that each worker is working efficiently and there is no overlap or conflict between different tasks. So ECS also ensures that, okay, it ensures that each container is running efficiently and there is no overlap or conflict. And we have enough number of construction workers. That is also the job of project manager, right? To ensure that enough number of construction workers are there. So that is also the work of ECS, to ensure that correct number of containers are getting running. So it will monitor, the project manager will monitor the progress of construction project and make the adjustment necessary. So ECS also monitors the performance of containers and make the adjustment to ensure that application is running smoothly and efficiently. So this is the task of ECS, okay, just to make sure that everything is running correctly in the containerized application. So you can run the containers. What is this doing? This is just the management service. Now, if I want to actually get the computation power, if I want to run any component of my application, I need the compute power for that. So where I will be hosting my containers? I can be hosting my containers either on EC2 or on Fargate. Right. What is Fargate? We would be understanding later in our slides, but you already know what is EC2, right? It is a virtual machine on which you can run your containers. So this is about ECS cluster. What happens over here is we have the ECR registry in which we would be having our images. So the images would be pulled out from the ECR registry and would be going to the ECS clusters. Right. So we have two services over here. So two microservices are there, order service and product service. Now here we have something called as capacity, service capacity. So service capacity in ECS primarily determines it is determined by the number and size of containers that are running in the service, as well as the resources allocated to them. Okay, so when we are creating the ECS service, then we can specify the number of desired tasks. So here I say if the service capacity is 3, okay, then 3 containers must be running. Here we need one more, okay. So 3 containers would be running and that will be launched to handle the service workloads. So you can understand this service capacity as think of a highway and the number of cars it can handle within given period of time. So just like, highway is having the capacity limit that determines the maximum number of car it can handle at a given time, the service has a capacity limit that determines the maximum workload it can handle. Okay. So again, if we think over here, I have given service capacity 3. Okay. So service capacity 3 basically means that the number of containers that are running a specific task for a service. So if we say order service, then 3 containers are required for running this order service. Okay. If I say product service, it requires 1 container to run the product service. Now I have said that cluster hosting capacity is 2. It means that I need 2 EC2 instances running in the backend. So here you have to configure while you are running your ECS on the EC2, then you have to configure the details about that. Okay, you have to say that how many EC2s are required, what type of EC2 would be required. All of that configurations and provisioning has to be done from your end. But in Fargate, you can avoid this. Okay, we would be talking about that later, but here you can see for order, we have 3 containers running, 1, 2, 3, because we have given the service capacity as 3, and for product, we have 1. And because cluster hosting capacity is 2, that's why we have 2 EC2 instances launched over here. Right, so this is about the ECS. Now, there are different components of ECS that we need to understand for getting the better understanding on ECS. This will also help us when we just go to the portal, okay, because all of these terminologies you would be seeing on the portal as well. So let us try to understand that what are these different services or say components. So the first component is container instance, right? So what is container instance? It is a virtual or physical machine that runs Docker container. So container instances are part of an EC2 cluster and they run the ECS agent software that will communicate with ECS service. So it will container instance, you can understand it as EC2, and on that EC2 one ECS agent would have been installed that can communicate with ECS service to manage those containers which are running on EC2. Then we have task definitions. So this is the blueprint for the application, defining which Docker image to use, how much of CPU and memory should be allocated to each container, and other such configuration details. Then the third thing that we have over here is task itself. So task is a running instance of task definition. So here we define everything, okay, that what all things are required, and here we actually execute, we run. So task is a running instance of task definition, running on a container instance. So a task would be running inside of a container. Each task runs one or more containers, and the container within the task share the same resources. Then we have services. So a service is a long running task that ensures a specified number of tasks that are running and replaces any that fails or become unavailable. Okay, so it can be used basically for providing high availability and load balancing our application. Lastly, if we talk about cluster, it is logical grouping of container instances and the tasks. So ECS allows you to create multiple clusters, each with its own set of container instances and the tasks. Okay. Now these were the official definitions. How we can understand this in some real world examples, because that would be easy. Why I am giving the real world example over here is because this is something new. Okay, and it is difficult to understand these concepts because containerization is something which is not generally done by everyone. Okay, so we need to understand this in a better way. So let's just try to understand it with the analogy. So again, we would be going to a restaurant. Okay, for understanding cluster, a restaurant is actually just like a cluster in ECS. Just as restaurant has tables and chairs where customer can sit and eat their food. Similarly, a cluster is a group of EC2 instances that can run containerized application. So that is cluster. Then we talk about task definition. So it is a recipe for a dish. So any recipe for a dish acts like task definition, because that's what we said, right? Task definition contains all the definitions and the configurations of the task that has to be run. So just like recipe specifies ingredients and cooking instructions, the task definition specifies the container images that has to be used, the CPU memory requirements, and the network configurations that are required for a container. Then if we try to understand container instances, so it is a chef in a restaurant. Just as chef prepares and serves the food to customer, a container instance runs the containers and serves them to the cluster. Then if we talk about task itself, then it is a plate of food. Just as a plate of food is serving of a particular dish, a task is running instance of a container based on task definition. Okay, task definition was recipe. So when we follow that recipe, what we'll be creating? We'll be creating that particular dish, right? So when we follow the task definition, we create the task. And when we follow the recipe, we create the dish. So you can understand it like that. Okay, let me just put it over here also for better understanding. So this can be understood as restaurant where EC2 instances can, it is the group of EC2 instances that can run containerized application. Then we talked about task definitions. This was analogous to our recipe. Task is analogous to our dish that is being, made by that recipe. Then container instance. It is just like chef. Okay, who prepares and serves the food. So the container instance runs the container and serves them to the clusters. And lastly, service. You can understand this as waiter. How as waiter? Because waiter in restaurant takes orders and serves the food to customer. So a service in ECS manages the tasks by ensuring that the specified number of tasks are running and replaces any task that stops or fails. So these are the analogies that you can use for understanding it better. Okay, these are the 5 important concepts, or say the components of ECS. Then what are the use cases? So you can use the ECS containers to run your web application, which requires agility, high availability, or scalability. So you can scale your web application as and when required. Okay, you can scale the number of containers based on demand. Then obviously we can use it for the microservice architecture because it allows you to manage and deploy multiple services independently. Just like we have seen in our previous slide, the orders repository was there. So we can create order service, we can create product service, we can create profile service. So each service can run independently over here when we are using ECS. Then we have batch processing. So it is also used for batch processing such as data processing or image rendering, video rendering. You can easily create a task definition that runs a batch job and you can schedule that task to run on the container instance. For machine learning workloads as well, we can be using the containerization because we can use the GPU enabled container instances to accelerate our machine learning workloads. Then we have DevOps. So this is basically very good, because we can easily build and deploy containerized application. So with ECS, you can integrate with other AWS services. We have talked about code pipeline already, right? So if you want to create this CI/CD or if you want to follow this DevOps methods, then you can use ECS as well because it will be easily integrating with code pipeline or code build. So any changes if done into the container image or container image, then that would be reflecting into our containers by that pipeline. Okay, we create the pipeline. So any changes made into the source would be deployed into the production environment also. So that is our CI/CD pipeline. So these are the different use cases, not limited to this. Obviously, you can use the containers and various other use cases as well. The next topic that we are going to understand is EKS, that is Elastic Kubernetes Service. So before we go with EKS, we have to understand the difference between the EKS and ECS, right? Or we have to understand what is Kubernetes. So first of all, we need to understand Docker and Kubernetes. Okay. What was Docker? So we have the Docker files and we run the Docker containers. We are talking about Docker since so long. So what is Docker, first of all? So if we take one example, okay, we have one app called Fifi. Okay, that Fifi is drowning into ocean. So a whale fish comes and put Fifi into one container, okay, one box. So Fifi was happy that, okay, it is comfortable in one box into a container, safe, running properly, okay, surviving. But then after some time, Fifi felt alone. That's when Captain Kubernetes comes into the picture. So Kubernetes basically means a pilot. Okay, it is a German word where it means, Kubernetes means pilot. So the captain comes into a ship, takes Fifi, labels it and puts it into one pod or one place on the ship. So now Fifi no longer feels alone or isolated, right? So for understanding Kubernetes and Docker, the whale fish that put Fifi into that container is actually Docker. And the captain or the pilot that put the Fifi into a ship by tagging it with a name tag is Kubernetes. Another analogy can be, we will again go to restaurant. This time we will be comparing Docker with Chef and Kubernetes or K8 with Manager. So Docker is just like a chef. who prepares and packages the food. It provides the tools and environments to create and package container images, which can be compared to preparing and cooking the food that is done by chef. So Docker is basically focused on individual containers, how they are built, how they are run, similar to how a chef is focused on individual dishes or how they are prepared. But Kubernetes, on other hand, is just like a restaurant manager who manages and orchestrates the food service. It provides the tools and environment to manage and orchestrate multiple containers across different machines, similar to how a restaurant manager manages multiple tables and orders. So Kubernetes is focused on overall system and how the containers work together, similar to how a restaurant manager is focused on overall dining experience. So Docker, if we understand, it is focused on individual container, and Kubernetes is focused on overall system of containers. Okay, so here now we are talking about EKS, which gives us the advantage of managing or orchestrating the overall system. Okay, so we are here. It makes easy to deploy, manage, and scale containerized application. So when you use EKS, it is a managed service. If you are not using the ECS and EKS, then also you can run the containers. You can run the containers on EC2. But when you do so, you have to install the Kubernetes and you have to install Docker engines on this EC2. And you have to manage those. But when you use the ECS and EKS, those management overheads are being reduced. So you can, it eliminates the need of installing and operating your own Kubernetes control plane. So instead, what it does is, it provides us with API endpoint, which we can use for interacting with our clusters. So again, when you are running the containers, ECS, EKS, both are the management services or orchestration services. But running actual compute would be provided to us by either EC2 or Fargate. Right. So now let us try to understand the difference between the ECS and EKS. Okay. So ECS is more of a native service of AWS. Okay, now let's try to understand this with another example. I know I'm giving a lot of example in this particular, module, but it's kind of important for us to understand the minor differences. So if we talk about ECS, okay, so we can take the analogy for traditional restaurant versus a franchisee chain. Okay, so if we talk about ECS, it would be like a traditional restaurant where the chefs. Now, again, let me just put this into a new slide. Let me just take one new screen. Okay, we have ECS and we have EKS. This is our traditional restaurant. Okay, and this one would be franchisee. So what happens into the ECS is, here, chefs and servers are managed by the restaurant owner. Okay, so when I say chef, it means containers. Okay, when I say servers, it means instances. So chefs and servers are managed by restaurant owner. So who is the owner? AWS would be the owner. So the restaurant owner controls the resources and the infrastructure, and the chef prepares the meals based on order received from the customers. So customers are what? Customers are the users of this ECS. So the restaurant owner can scale up or scale down the number of servers or chef to handle the workload, but the customer have no visibility or the control over the underlying infrastructure. So this is about ECS. It is managed service and it is native service of AWS for containerization. If we talk about EKS, it is just like a franchisee chain where each franchisee operates a restaurant using a standard set of rules and processes. So, if we talk about franchisee, it would be user. And when we talk about set of rules and processes, okay, set of rules and processes. So these standard set of rules and processes are being set by Kubernetes. So that is Kubernetes. So the franchisee, whoever is owning the franchisee, okay, is responsible for managing their own resources and the infrastructures, including chefs and servers. So chefs again are the containers. So users are responsible for managing the containers as well as the instances over here. Franchisee can scale up and down the restaurants to handle the workload, and customer can interact with the restaurant using standardized set of rules and processes. So in summary, ACS is a fully managed service where AWS handles the infrastructure and resource management, while EKS provides a standardized set and rules and processes for managing the containers and infrastructures. So ECS is more suitable for the simpler workloads that do not require the complexity and the flexibility of Kubernetes, while EKS would be more suitable for the complex workloads that require advanced container orchestration and management capabilities. So this would be the difference between two. Okay. The next topic that is to be discussed about is components of EKS. So there are these 7 different components that we are going to discuss. So the first component is control plane, right? So let us understand what is control plane. It is the management plane of your Kubernetes cluster. It includes API server, etcd, and other control plane components that are responsible for managing the state of cluster, scheduling workloads, and handling API requests from all the clusters. Okay. The next component is worker node. So worker nodes are the compute instances that run your containerized applications. These nodes can be launched in your own AWS account, or you can also use AWS Fargate to run your containers without needing to manage the underlying infrastructure. The third one is Kubernetes API server. So it is the central point of control for your cluster. It exposes the Kubernetes API, which is used to manage resources in the cluster. etcd, it's a distributed key value store that is used to store the state of your Kubernetes Kubernetes cluster. It is used by control plane components to coordinate and synchronize cluster state. Then we have Kubernetes scheduler. So the scheduler is responsible for scheduling pods onto the worker nodes based on resource availability, quality of the service required, and other factors. Then we have Kubernetes Controller Manager. So the Kubernetes Controller Manager is responsible for running controllers that manage the state of Kubernetes resource such as pod, services, replica sets, etc. We have CloudFormation. It is a service which will help you model and set up your EKS as well. Okay, we have already talked about CloudFormation before. So apart from that, I would also like to add a few components over here, which is pod, service, and replica set. Okay, so majorly I would be giving you the analogy for pod, service, replica, control plane, and the worker node. Okay, so let's understand this with the help of analogy. So here again we would be taking the example of chefs working in the restaurant kitchen. Okay, so pod would be like a single chef responsible for, so I'll just mention it over here. This would be single chef responsible for preparing a specific dish. So pod would have its own resources such as utensils, ingredients, and would work independently to create the dish. However, just like how a chef can collaborate with other chefs to create more complex dishes, multiple pods can work together as a part of larger application or a service. So service in the Kubernetes would be like the front of house staff in a restaurant. The service would act as a gateway to the pods, providing a consistent endpoint for customers or users to interact with it. So this would be just like front door. Just as front of house staff directs customers to specific tables, a Kubernetes service directs incoming requests to the appropriate pods. Okay, so this would be front door staff. Then we have replica set. So replica set in Kubernetes would be like having multiple chefs preparing the same dish. So replica set is responsible for creating and managing multiple identical pods to ensure high availability and scalability. So this would be like multiple chefs. Okay. Lastly, we have the control plane. So for control plane, it would be like the executive chef in the restaurant. So the control plane manages the overall operation of the clusters and ensure that each pod is running as expected. So just as an executive chef monitors the work of each chef in the kitchen and adjusts the menu or the staff as needed, the Kubernetes control plane monitors the status of each pod and adjusts the resources or configurations as required. Okay, so these are some of the analogies by that you can understand it in a better way or you can remember it in a better way. And if we talk about the worker node in Kubernetes, it could be think of a team of chefs working in the restaurant. Okay, worker node would be the source chef responsible for supporting the main chefs, that is pods. Okay, so they would be just the helper chefs and they will execute specific tasks. So worker nodes provide the resources and the infrastructure for the pods to run. Just like we have the supporting chefs which support the main chef by preparing the ingredients or cleaning up, performing other tasks as needed. So these are all the components of EKS. Now the last topic that we have over here is the use case for EKS. So it is used for running the containerized microservices. Right, obviously we have to, if we want to run the microservices, then we can have this Kubernetes and we can have scalable and flexible platform for running the containers. Then we can deploy the machine learning workloads over here. So again, it will provide a platform for running and scaling the training and inference workloads. It is used for building CI/CD pipelines. Because it can again integrate with other AWS services, then CI/CD pipelines for your containerized application can be easily built using EKS. We can run the batch processes on EKS like video transcoding, rendering, data processing. So you can run these workloads at scale and you can also schedule these workloads. You can run the web applications as well, providing platform for deploying your applications into highly available and the scalable environment. So this is all about Kubernetes over here, or say EKS service of AWS. So the last topic for this particular module is Fargate. Okay, so we are learning since long that, or we are listening since long that we can run our we can run our containers on either EC2 or Fargate. Right, both of them are possible for hosting our containers, or to get the compute power for containers we can use EC2 or Fargate. Right, so what is Fargate basically? EC2 we already know that we have to provision the EC2, that how much of RAM, how much of memory is being required, how many cores or vCPUs we require. So we have to manage the underlying infrastructure. But if you understand about Fargate, then it is a serverless compute engine for containers that allow you to run the containers without having to manage underlying infrastructure. So you do not have to worry about what infrastructure is there in the backend on which our containers are running. Okay. So because it is serverless, you have to pay only for what you are consuming, truly pay per you use model, and you can launch your Docker containers in seconds on Fargate. So it integrates with the ECS as well as the EKS, allowing you to use the same tools and workflows that you already know. Okay, it is just the hosting service. The compute that is being required for running our containers would be provided to us by using Fargate instead of EC2. So it provides a highly available and scalable platforms for running your containers, and it also have automatic scaling and self-healing, which is built in. So it basically allows you to just focus on developing your applications and deploying it without having to worrying about underlying infrastructure. So this is the importance of Fargate. Now again, I'm reiterating, you can run your ECS or EKS both on either EC2 or Fargate. Okay, if you go with EC2, here the efforts would be more, here the efforts would be less, because it is a serverless service. So you don't have to worry about underlying infrastructure. Here you have to manage your infrastructure in the form of EC2 instances. Right. So that's it for the theory portion of this module. We have to understand, we'll see one tiny demonstration for ECS over here, right? So let's not waste any time and let's see that how the ECS works. Okay everyone, I'm on to my AWS console, right? So we have to go to ECS service over here. So I'll go to ECS, that is Elastic Container Service, and we would be creating one cluster over there. Okay, let's see that how this goes. So let it load over here. So you can see we are on the clusters page, right? So we have to create one cluster over here. Let me create it. Let's say I'll just call this cluster as demo cluster. I want it into the default VPC. All the subnets are being already selected. The namespace specifies the group of service that make up your application. So this would be again demo. By default, the name of cluster is used for that. So I'll just put that itself. So how do you want your infrastructure? Okay. So cluster is automatically configured for Fargate with 2 capacity providers. Add Amazon EC2 instances or external instances using ECS anywhere. So if you want, you can do so. If you want to add, EC2 instances over here, you can go with that. But by default, it is already having the Fargate, that is pay as you go model. Fine, so I'll just keep it as Fargate. I don't want any monitoring or tag options. So I'll simply click on create over here. If you select EC2, then you have to give the EC2 instance type. Okay. So we will wait for this demo cluster to get created. Once it gets created, we'll be going to our task definition. And we can create a new task definition and we can run the tasks, right? We can launch our task by starting the service. But we have to wait till the time this demo cluster is getting ready. So let's wait for that time. The default cluster is already there, as you can see. Okay, no services are running over here. See that our demo cluster is ready, right? I'll go to the task definition now. Into the task definition over here, I'll say that create a new task definition with JSON, because I already have one JSON snippet with me for creating the task. Okay, this is the JSON that I have. You can see it over here. We will just click on create. So the task definition is successfully created over here. So we have till now created the cluster and the task definition. Now we have to create a service using the task definition. So again, we'll be going back to our cluster. Into cluster, I'll go to my demo cluster. And over here, if you scroll down, you'll see the services, right? So we will click on create over here. And once we are creating the service, we would say into the deployment configuration, we will say we have to specify how the application is being deployed. So for task definition over here, we would be selecting our task. That is sample Fargate task that we have. Okay, this is the latest version that we are going to use. We have to specify the desired task. And I'm good with one task. Okay, I don't want to have any more tasks. And a task group. So we would just put here all the tasks with same name group are considered as a set, and they are placed into the spread placement. So we will just put it as group. Okay, once everything is done, we'll just click on create. So a service got created and it is getting provisioning. Okay, once it gets provisioned, we can go into the configuration over here, and then we will be able to see okay, just give me 1 minute. So you can see over one task is running, right? I've created one service as well as task. Okay, so here under the task, we have this task running. I'll go inside of that task, and what I'll do is I'll go here under the configuration, scroll down, and when I try to open this public IP address, okay, so when I open this public IP address, it says that this is Amazon ECS sample app. Congratulations, and your container is running on ECS now. Because this is just a sample application, okay, we do not have any custom code over here. If you want to have a custom code in your task definition, or if you want to give your container image, then also you can do it, right? So this was about the demonstration of our ECS. Okay, so that's it for this particular module. We do not have much over here now left. We have seen the demonstration, we have seen the theory, and we have learned so many things into this module. Let us just quickly revise all those things. So in this module, we started with the microservices, right? What are microservices and what was monolith? We have discussed about the features of both, and just give me a minute, monolithic. Right, we have seen the difference between two. Then we started with containerization. That what is this concept of containerization? Containerization, right. And later on, we got to know about what is container image, how we can run our containers, right, on like generally how we can run our containers, what is the process. So there were 3 steps into that process, right? First of all, what we do is we pull the image out of registry, we create the container out of that image, and then we run the container. Okay, so for that we do have different kind of services, like for pulling the image. So where we'll be pulling the image from? We'll be pulling it from ECR, that is our Elastic Container Registry, native to AWS. Then we can create the containers on ECS or EKS. We have understood the difference between the two. Then we have also understood the difference between Docker and Kubernetes by some good analogies over there, right? And for hosting the containers, for getting the compute for running our containers, we have 2 options again, EC2, and we have the option of Fargate. So Fargate being the serverless option and EC2 being the provisioned options. So we have to manage this EC2, but we do not have to manage the Fargate if we use. And lastly, we have seen the demonstration as well, in which we have created one sample task definition, and through that task we just saw that how it opened up one web service, right? So that's all for this particular module. Thank you so much.